Hello everyone. Thank you very much for being today. And my name is Uma. Today I will be presenting my portfolio project, AI-powered electric vehicle battery shape classification systems. In this project, focuses on applying computer vision and deep learning models to automate the process of identifying battery shape classification. The aim of the project is improving efficiency and recycling of the battery shape process. So, recycling marketing. What is the why it is so important recycling of the process? As you know, electric vehicle manufacturing is growing extensively, and the more EVs are produced every year, and a larger number of electric vehicle batteries are reaching their life end to stage. So, from business perspective, in 2024, global EV market for reprocessing valued around $500 million and expected to grow 10 times faster by 2030. So here recycling enables the efficiency. Yes. Then let me explain. Let me ask you one thing. Why recycling process is so important? What is happening when battery is reaching of its end stage? So we have to do the recycling process for all the batteries. For example, if you want to do recycling process for most of the facility units still following manual process to identifying the batteries. So for example, if you want to do the manual process, it is very expensive and cost effective. It is very difficult to perform on large volume of data sets. Okay, let's take if I want to perform 100,000 images, what will be the cost? Daily, I mean, per hour wage will be 25 euros, and by to inspect the shape of the battery, it might take 20 to 30 seconds. So overall, the cost around like $7,000. So in contrast, if you implement AI solutions for the same to process 100,000 images, definitely it costs around $200 to $500. So definitely we can reduce the cost by 80 to 90% while increasing the efficiency and scalable on the large volume data. So let us see here battery types. Primarily in electrical vehicle, there are three main battery types. Firstly, cylindrical. It is in the round shape, and commonly these type of batteries being used in Tesla cars, packaging of 4,000 batteries. So secondly, prismatic. It is in the regular shape, and it has very sharp edges, and mostly these kind of batteries being used in BMW, Mercedes-Benz and Volkswagen, pack of 100 cells. Thirdly, pouch. It is very flat and it has round edges. Mostly these kind of batteries being used in Hyundai cars. So the major challenge of this project is to identify the correct classification of the battery based on the shape, because these two batteries, prismatic and pouch, are looks very similar in the rectangular shape. So data set and data collection. I have got the data set to implement my idea to classify correctly on the battery shape from recycling battery 24, which is sourcing from Zenodo. So they are providing around 2,800 images with RGB. Then from the available data set, I have just extracted mass to have the pixel level battery shape by isolating, from the background. So from the mass, I have extracted still the cutouts to get more accuracy to to extract the region of the battery to avoiding or to reduce the noise from the background. So finally, cutouts will be my input to process the entire thing. So data pre-processing and slits. Mm, I have categorized with the available data into three categories: training set and validation set and test set. Training, I will be processing my model to learn most of the patterns during training thing. Most of the portion has been allocated to the training set, and the validation set used for hyperparameter to tune the model. And the test set, I want to test how my model is performing on the unseen data. Then this is my model architecture. Here, I will just briefly explain about technically. I have designed two AI powered pipelines to get more accuracy based on the shape. And when you upload an image of base image of RGB, it will process to UNet segmentation, and from UNet we can create mass from the available base image. From the mass, still we can get cutouts by uh, uh, getting all the features without missing anything from the edges. So from the cutouts, we will get the feature extractions, then we will pass it to ResNet classification. From ResNet classification, we can predict how model is performing, whether it is predicting the correct image based on the classification. Here I wanted to highlight two things: UNet segmentation and ResNet classification. UNet segmentation, UNet architecture, it helps to create the mask by removing the background, and which improves the classification accuracy. ResNet is the main reason to choose the ResNet model is it will perform very well on the image classification, and also it is very scalable to on the limited data set. We are having only 2,800 images. Out of 2,800 images, we have split into 50 and 25-25 ratio. Training, we have given almost all 1,400 images. So what are the strategies we are following here to experiment my idea? Um, and I have been tracking confusion matrix and F1 scores metrics to how my model is performing. So results and performance. From the training data, almost all I got 99% because I have been using cutouts, which is capturing very accurately sharp edges, uh, and processing through AI powered pipelines. And test accuracy, I got 83% because cylinder batteries classified most accurately, but there is a confusion between prismatic and pouch batteries. Because of that, I got only 83% accuracy on unseen data. So I have uploaded, or I have tested by uploading the image in Fast API endpoint, and I have got almost all for cylindrical 96%, and I have implemented Streamlight interface where user can upload their image and they can see how mass and cutouts are being displayed for the uploaded image. Yeah, so I'm able to implemented successfully cutout based EV batteries classification. So the model learns specific features effectively, and it has been achieved good generalization on the unseen data. It is available, it is scalable and deployment ready. So future enhancements, maybe we can increase large volume of data, and we can implement lightweighted models still to improve the accuracy. And yeah, and just I wanted to say thank you to Antonio, who has mentored for this project.